All right, hello. So we are going to begin lesson 8.3. It is a 2-day lesson, so this is day 1. I have some vocab already written up, so we're going to jump right in, okay? So we're going to start talking about geometric sequences. A geometric sequence is a sequence in which the ratio of any term to the previous term is constant. So arithmetic had a common difference, some way that we were adding or decreasing from one term to the next. Here we're going to have a common ratio. So we're going to be looking for what are we multiplying by to get from one ratio or from one term to the next. All right, the common ratio, the constant ratio R between consecutive terms of a geometric sequence. So D was a variable we used for common difference. R is a variable we use for the constant ratio. And then we have a rule for writing a geometric sequence, and that rule is a sub n equals a sub 1 times r to the n minus 1. A sub 1 stands for the first term. R is the common ratio. All right, so the first set of problems we're going to look at, we're going to tell whether each sequence is geometric. Okay, so we need to figure out, is there a constant ratio? Is there some number we're multiplying by to get from this term to that, and then this term to that, and then this term to that, and so on and so forth, okay? So you may already be able to just look and determine whether or not there is a common ratio. I'm going to show you how to set it up, because if the numbers are, not ones that it's easy to identify what you're multiplying by, we need a method. All right, so to find a common ratio, what you're going to do is you're going to take a term and put it over the previous term. So for example, a sub 2 over a sub 1. So if you take the second term and put it over the first term and simplify, you can see, all right, and you probably all knew, you're multiplying by 2. Now if I take the third term and put it over the second term, so now the third term over the second term, so I'm going to have 20 over 12. All right, what are they both divisible by? They're both divisible by a 4. So 4 goes into 25 times. 4 goes into 12 3 times. So that means to get from 12 to 20, you're multiplying by 5/3. We can actually stop here. As soon as you see it is not common, the ratio is not common, you can stop. But I'll just do one more. A sub 4 over a sub 3. So I'm going to have 30 over 20. Simplifies down to 3 over 2. So I'm multiplying by 3 over 2. Okay, and again, I could do the last one, but I can stop. All right, I can say no common ratio, therefore not geometric. Okay, no common ratio, therefore not geometric. All right, in the next problem, again, to figure out the common ratio, you're going to take the second term, put it over the first, or the third term and put it over the second, or the fourth term and put it over the third. Okay, so a sub 2 over a sub 1, that's 256 over 64. Back up so you can see what I wrote. All right, that's going to simplify down to, I set it up wrong. Hold on a second. I said a sub 2, but then I wrote a sub 1. Start over. So it's 64 over 256, which simplifies down to 1/4. Okay? So that means we're multiplying by 1/4. Now if I set it up a sub 3 over a sub 2, it's going to be 16 over 64. Which also simplifies down to 1/4. So multiplying by 1/4. All right, a sub 4 over a sub 3. A sub 4 over a sub 3 is 4 over 16, which is 1/4. And then the last one would also be 1/4. So for this one, the common ratio r is equal to 1/4. Therefore, yes, it is geometric. Okay, so that is how you determine whether or not a given sequence is geometric or not. All right, let's move on to the next problem. All right. So let's see, example 2. We're going to be asked to write a rule for the nth term of each sequence. And then you're going to find the eighth term, a sub 8. Then find a sub 8, the eighth term. Okay? And we have 2 to look at. So the first is 5, 15, 45, 135, ... And the second problem we're going to look at is 88, negative 44, 22, negative 11, ... Okay. So we need 2 key pieces of information in order to write the rule. Just like with our arithmetic sequences, we needed to know the first term and the common difference. For arithmetic, you need to know, or excuse me, for geometric, you need to know the first term and the common ratio r. Okay? So first find the common ratio. Make sure it is geometric. So what am I multiplying by to get from one term to the next? Again, if you can just look and identify it, that's fine. All right, times 3, 15 times 3 is 45, 45 times 3 is 135. So I know my R value is 3, and just by looking at the I wrote a Q, just looking at the sequence, I know my A sub 1 term is 5. Okay, so writing the rule down, this one right here is what I'm referring to. We're going to have A sub n equals the first term, which is 5, times R, which is 3, raised to the n minus 1. And that's it. There's nothing more to do, no simplifying. You can't multiply the 5 and the 3 together because order of operation. We're going to have to work with the exponent, apply the exponent to the R value, and then multiply. So don't multiply those together. It's not 15 raised to the n minus 1. Okay? All right, for the next problem, same thing. First, find the common ratio. Make sure it is geometric. So here, I'm multiplying by negative 1/2. 44 to 22, multiply by negative 1/2. 22 to negative 11, multiply by negative 1/2 as well. So my R value is negative 1/2, and A sub 1, the first term, is 88. Okay. So just filling in that information to write your rule, you have A sub n equals the first term, 88, times negative 1/2 raised to the n minus 1. Okay. I just realized I actually didn't finish up problem A because we're asked to then find the 8th term. Again, you could extend the pattern, right? You could keep multiplying by 3 until you get to the 8th term, but we're going to use the rule. So for the 8th term, A sub 8 is equal to 5 times 3 raised to the 8 minus 1. Follow order of operation, please. You're going to take 8 minus 1 first, so it's 5 times 3 raised to the 7th. Evaluate the exponent next. So you're going to do 3 to the 7th, and then after you do 3 to the 7th, you multiply by 5, and that's going to give you 10,935. So 10,935 is the 8th term of this geometric sequence. Okay. For this problem, finding the 8th term, trying to see where I have room. Maybe I can go down. The 8th term is going to equal 88 times negative 1/2 raised to the 8 minus 1. So you're going to have the 8th term is equal to 88 times negative 1/2 raised to the 7th. So you're going to do negative 1/2 raised to the 7th and then multiply that by 88 to get negative 11 over 16. So the 8th term is negative 11 over 16. Okay. So that is it for example 2. Let's move on to the final example for today. And because I need some extra room, I'm going to erase the entire board, so give me just a minute. Red does not want to come off. All right. Okay. So for the last example for today, example 3, I'm going to shorthand the directions just so I don't have to write so much. So for this one as well, we're going to be asked to write the rule and then to graph the first 6 terms of the sequence, but we're starting with different information. Okay, so we're given that the 4th term is equal to 12. We're given that the common ratio, the R value, is 2. And we're asked to write the rule for the nth term. And then we're going to graph the first 6 terms. Okay. So, think about the information we need in order to write the rule. We need to know the R value, which is given, and we need to know the first term, okay? Now, yes, you know the 4th term. You could work backwards to get to the first term since you know the common ratio, but that's not how I'm going to do it. Instead, we're going to use the rule, the formula. So step 1, we're going to find A sub 1. That's the missing information we need in order to write the rule. So I'm going to write down A sub n equals A sub 1 times R to the n minus 1. I'm going to fill in all the information I know, and it's going to leave me with just one unknown, that's A sub 1. So since the 4th term is 12, A sub n gets replaced with a 12. I don't know A sub 1. I know my common ratio is 2. And that's raised to the 4 minus 1. Where did the 4 come from? The 4th term. 4th term is 12. Okay? Now, I can solve for A sub 1. So I'm going to have 12 is equal to A sub 1 times 2 raised to the 3rd. All right, you're going to evaluate 2 raised to the 3rd. 2 times 2 is 4 times another 2 is 8. So I have 12 is equal to A sub 1 times 8. Now, getting A sub 1 by itself, I'm just going to divide both sides by 8. Now, I have A sub 1 is equal to 12 over 8, which, of course, we're going to simplify that fraction. Both are divisible by 4, so 3 over 2. Now that you know your first term is 3 over 2, you can write the rule. So, step 2. Write the rule. So, A sub n equals A sub 1 times R raised to the n minus 1. We're going to fill in A sub 1, which is 3 over 2. You're going to substitute in the R value, which is 2, raised to the n minus 1. That is the rule for this sequence. Okay, the next step is going to be to find the first 6 terms. Okay, so step 3, find the first 6 terms. So using the rule, a sub 1, the first term, is equal to 3 halves times 2 raised to the 1 minus 1. 1 minus 1 is 0. Okay, so I have 3 halves times 2 raised to 0. Anything raised to 0 is just a 1. So now it's 3 halves times 1, which is 3 halves. Which is good because we said the first term is 3 halves. The second term, 3 halves times 2 raised to the 2 minus 1. 2 minus 1 is 1, so it's 3 halves raised to 2, or times 2 raised to the first. 2 raised to the first is just 2, so it's 3 halves times 2, which is 3. Okay, and you're going to keep on going. The third term, 3 over 2 times 2 raised to 3 minus 1. So it's 3 halves times 2 squared. That's 3 halves times 4, which is going to give you 6. Okay? But also keep in mind, since you know the common ratio is 2, we're going to multiply by 2 each time. So now that I know 6, I know, and I'm not going to do all the math this time, that my fourth term is going to be 12 because I multiply by 2. And my fifth term, multiplied by 2, is going to be 24. And my sixth term, multiplied by 2, is going to be 48. Okay? Because I know my common ratio. So I kind of took a little shortcut there just to save some time. And the last step is just to graph. So I'll do a quick little graph. I think I might need to erase, make room. I'll erase step 1, give myself a little room over here. All right, so when you go to graph, n, and then n sub a. So these are the terms: first term, second term, third term, fourth term, fifth term, sixth term. I know that it goes everywhere from, this is 1.5 if you want to think of it in decimal form, from 1.5 all the way up to 48. So you might want to change your scale. I think I counted by 5s on my answer key. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And then you just approximate where they should be located. So the first term is 1.5, so term 1, and just go like right above. The second term is 3, so a little bit higher. The third term is 6. The fourth term is 12. The fifth term is 24. And the sixth term all the way up here at 48, something like that. Okay? And you don't connect the points, you just plot them. All right, guys, that is the end of lesson 8.3, day 1. So meet me back here for lesson, or part 2, day 2. Bye.